Let's solve this problem. A charge Q located at a point R is in equilibrium under the electric field of three charges Q1, Q2, and Q3. And the location of the two charges Q1 and Q2 are R1 and R2 respectively. Now we have to find out the direction of the force on charge Q due to Q3 alone we have to find out. So let's understand this question by drawing the vector diagram. So let's take the frame of reference this way, X, Y, and Z. So this is a point charge Q1 and the position vector of this Q1 is R1 vector. And now we have charge Q and the position vector of this charge is R vector. And there is another charge Q2. The position vector of Q2 is R2 vector. Q3 is somewhere in the space. We have to find out what is the force on this charge Q due to Q3. And it is given the charge Q is in equilibrium, which means that the total force acting on charge Q should be zero. What does it mean? The force on charge Q due to Q1 plus the force on charge Q due to Q2 plus the force on charge Q due to Q3 should be equal to zero. All these are vectors. Let me just write this as F1 vector, this as F2 vector, plus this as F3 vector. And they should be equal to 0. And we have to find out what is F3. So which means that F3 equals minus of F1 plus F2. So the idea here is find F1 according to Coulomb's law and find F2 and sum them. Give a negative sign that will give the direction of the force F3. So let's do that. So first, according to Coulomb's law, the force between Q1 and Q should act along the line joining these two charges. Let me call it acts in this direction, and I can write this as R minus R1 vector. And similarly, the force on Q due to Q2 acts along this direction, and this vector is R minus R2 vector. Let me just write this as like a capital X vector as R vector minus R1 vector, Y vector as R vector minus R2 vector. Now let's write F1 according to Coulomb's law. F1 vector, which is actually the force on charge Q due to Q1, that's equal to 1 by 4 pi epsilon naught Q1 divided by X squared and X cap. This can be written as 1 by 4 pi epsilon naught Q1 divided by R minus R1 vector whole squared. And according to the unit vector definition, we can write X cap as R minus R1 vector divided by R minus R1 vector and its modulus. Similarly, we can write F2 vector, this charge on Q due to Q2, which is 1 by 4 pi epsilon naught Q2 divided by Y squared Y cap, which is actually 1 by 4 pi epsilon naught Q2 divided by R vector minus R2 vector modulus whole squared, and Y cap vector can be written this way, vector divided by its modulus. That's all. We found out F1 and F2. We have to sum them now. When we sum F1 plus F2 gives you Q divided by 4 pi epsilon naught. And I can write this as Q1 divided by R vector minus R1 vector whole squared. Okay, let me write this as R cube itself because these two can be combined. Okay, and now I can write this as R vector minus R1 vector plus Q2 divided by R vector minus R2 vector modulus cube, and I can write this as R vector minus R2 vector. Now we have just written here because they are in equilibrium, F3 equals minus of F1 plus F2. So let's write that here. F3 vector is equal to minus Q divided by 4 pi epsilon naught. Write the same thing again. R vector minus R1 vector cube, R vector minus R1 vector plus Q2 divided by R vector minus R2 vector cube, R vector minus R2 vector. This can also be written in this way, that is F3 vector equals, bring this negative sign inside, Q by 4 pi epsilon naught, Q1 divided by R vector minus R1 cube. Now I can write this as R1 minus R vector because I have brought the negative sign here, plus Q2 divided by R vector minus R2 whole cube, R2 vector minus R vector, once again the minus sign is inside. And that's all. So we have got the force on charge Q due to Q3 in terms of Q1, Q2, R1, R2 and R. Thank you.